Yep. So good evening, guys. I'm Nipun Parekh, and I am AWS User Group Rajkot leader. So we AWS User Group Rajkot, Indore, Jaipur, and Kolkata has came up with the session, amazing session on the 5G and edge computing use case implementation in AWS. I hope you all are very excited to attend this amazing session. And guess what? Who is our speaker? Our speaker is Abhinivesh Jain. He is the chief architect at Wipro. And do you know, guys, how much experience he is having right now? He is having 20 years plus of experience, and he is also having 20 plus certification inside the cloud and the DevOps domain. So, isn't it amazing? So, without wasting much time, let's listen from the speaker only. So, let me welcome Mr. Abhinivesh. So, hi Abhinivesh, how are you doing?
I'm good, Nipun. Thank you.
Sure. So, Abhinivesh, our all the people who are joined are interested to learn new things from you. So, are you excited to deliver the session?
Absolutely. Yeah.
Yeah. So, I am handing this session to you, and now I'm overing session to you.
Okay. Thank you, Nipun. And thank you all for joining. Unfortunately, my throat is not in right shape, so you are hearing a different voice, but I'll try to manage. Okay. So, in this particular session, I'm going to cover what is 5G and what is edge computing because many of you might not be knowing that. And then we will jump into AWS specific solution in these two areas and how do we really implement those solutions and a quick summary. About me, I'm AWS ambassador. I'm working as director and chief architect in Wipro AWS business group. I'm also a distinguished member of technical staff, and I'm an author and blogger. And before I begin this session, you might have heard this news that today we have officially got 5G launched in India. So I'm delivering this session all the way from Delhi, where uh, uh, in India Mobile Congress, our Prime Minister launched 5G. So perfect day for us to talk about 5G and private 5G and edge computing and everything else, right? And this is not new. I mean, in terms of AWS world, there are so many news. I have just picked up three. So the very recent one was private 5G, which became generally available now. It was announced in last reInvent. And then there are companies which have already implemented 5G in AWS cloud. So there are stories about it. And there is a dedicated section in AWS which is called AWS for the edge, right? So all hyperscalers are having dedicated focus on telcos. And why so? Reason is that it's a very big market. The way 3G changed our entire life, right? Where mobile app came into picture and rest, uh, and 4G gave us more speed, and then we started living in different world, right? And 5G is going to uh, have that kind of impact, right? And just imagine the impact that it will have on existing kind of digital world, right? So if you happen to attend these India Mobile Congress or Mobile World Congress, you will see some amazing demos and uh, really prototype of things how 5G is helping or will help in different industries. So, what is 5G? As you know, it's a next generation of mobile network. So, what happens in telcos? Every 10 years, a new generation starts, right? So, and it takes like 4 5 years to roll it out. It's such a big change that it goes on for a very long time. So, right now, we already have 5G, but 4G is still present. And 4G is not going to go away for next 10 years or so. Like, I think very recently, we kind of discontinue 3G, right? So there is overlapping period, and 5G is a revolution. It's not like incremental upgrade from 4G. It's a fundamental change, and it is already rolled out in several countries, and now we can say it is already rolled out in India also. And there are three characteristics of 5G. These are the characteristic. One is enhanced mobile broadband, right? This is, I think, fundamental aspect that is expected from all new generation, right? We expect faster speed. Then another capability uh, which 5G brings is MMTC, which is massive machine type communication. So this is like all kind of IoT communication falls under here. And then comes URLLC, so ultra reliable and low latency communication. So what it means is that our network should be ultra reliable. I mean, it should be always available, right? And it should also provide us low latency communication. And we will get into detail of this. So out of these three feature, sorry. So the first one will be the primary driver or initial driver, because everyone is looking for faster broadband speed. Now, what is edge computing? Edge computing is again not a new concept. It has been there at least from a decade. Earlier, it used to be called fog computing, or there are so many names given to edge computing. And primary purpose of edge computing is whatever we are doing in cloud, uh, just bring that cloud to edge. And what is edge? Edge means, see, cloud is nothing but centralized location, right? So uh, and those centralized location in AWS world is AWS regions. Now, if we start serving things from AWS region, then we will not be able to handle low latency applications, right? So, let's say in US you have US East and US West, two big regions, and if there are users which are not falling in these two regions, they are somewhere in between in US, and we serve application from either side of the US, latency will play the picture and you will not get the optimal performance. And if there are real time application like autonomous car or maybe robotic surgery, there you can't afford any kind of latency, right? So if a doctor is doing surgery remotely, uh, he should, I mean, whatever operation he's performing, it should happen then and there, right? And it should be ultra reliable, because if there is a delay of, if there is a discontinuation in between, it will be dangerous. So, and that's where the need of low latency and real time kind of application. Uh, some of the example, cloud gaming. So earlier gaming was primarily driven by these big gaming consoles and all, right? But with edge computing, cloud games will be delivered without those console. And in fact, today in IMC, I've seen a lot of demos around it. And high quality video delivery, uh, like right now we are watching HD content and all from our mobile network, but soon we will see 4K and 8K content also, because we will have higher bandwidth, right? And this is a big market. So if you see the report, it says it's going to be like 800 billion market. And that's the reason why most of the companies, so when I say most of the companies, I'm talking about companies which are directly involved in this, like telco providers, or NEPs, which are network equipment providers like Nokia, Siemens, or uh, company which are providing software to this, or company which are providing system integration capability, and startups. So all kind of companies are part of this to get a pie of this big money that is there, right? And data processing habits are also changing, and data generation is now happening outside the data centers, and all of us know, right? So and Gartner predicted this long back in 2018, that by 2025 we are going to get 75% of data which will be processed at the edge. I mean, right now what is happening, your data is being generated at the end, and it is being sent to your application, which is somewhere in the cloud or at the central location. So what you're doing, you are moving massive amount of data, and if the data volume grows, you will choke that bandwidth, or you will choke that pipe, right? And so what you want to do, you want to do let's say artificial intelligence at the edge. So those are the kind of use cases. Now, how edge computing and 5G are related. So before getting into that, I want to explain a concept called MEC. Earlier it used to be called mobile edge computing. Right now, it was renamed to multi-access edge computing because mobile is not the only way to get connected to telco network. There are fixed wireless access, broadband access, Wi-Fi access. So multi-access means any kind of access that connects you to uh, that gives you connectivity is like multi-access, right? And MEC term is widely used in telco context, and ETSI has given a lot of MEC standard, like how do we implement ETSI. Now, where edge could be present, it could be at the near edge or far edge. And there are so many types of edge. If you try reading it, you will uh, hear at least 20 different type of edge: near edge, far edge, thin edge, thick edge, device edge, user edge. I mean, it's like anything and then edge word is added, right? So it's very confusing, right? But for simplicity, let's just focus on two types of edge: near edge or far edge. Near edge means edge which is closer to core data center of a telco company, right? And far edge means it is far away from your telco core data center. So it could be at customer premises, or it could be at device edge also, right? So what happens, as I said few slide back, URLLC is one of the key capability that 5G brings. And how does it bring? It brings through edge computing, right? So see, no matter how fast internet becomes, or how fast these next generation of mobile network becomes, we cannot defy law of physics, right? Where if there is a distance, round trip time is going to increase, latency is going to come. So if we are 1,000 kilometer away from your, so your source and destination are 1,000 kilometer apart, uh, there will be latency, right? It will be, and it will increase by your distance, right? So if you want to give low latency, the only way to do low latency, and we are talking about low latency like less than 1 millisecond, less than 10 millisecond, less than 50 millisecond. Currently in cloud computing world, we get like 100 millisecond kind of latency, but for these kind of application, we are talking about less than 10 millisecond latency, right? So what I was trying to tell, that only way to get low latency is to get the processing done closer to the source, right? So don't bring your entire application logic and data to core and process and then send the result. Imagine a situation where you are driving autonomous car, and autonomous car is connected to cloud, which is true even now, right? All the new cars have eSIM installed, and that's how it is always connected. So in autonomous car, if there is a latency of let's say 20 millisecond between your car, which is always on the move, and cloud, then what will happen? The decision making will be delayed, right? So if it has to apply brake or on its own by certain parameter, it might not get the right input at the right time, right? So there might be fatal accidents and all. So it becomes very important uh, to avoid, or not avoid, I mean, have minimal latency. And there are very interesting models coming up around autonomous car, like how, I mean, it's like a data center on the move. It is that kind of example of edge computing where your autonomous car is going to have a mini data center actually. So all kind of servers, hundreds of sensors, and it is not going to rely on cloud computing. It will rely on your data center, right? And for getting the information, let's say there is an accident a 500 meter away, whatever, that kind of information it will get from nearest edge site, right? So those are some very interesting use cases of edge computing. and it's absolutely necessary. And in today's we understood a little bit about 5G and edge computing, hopefully. So what are the AWS offering in this space? So uh, there are three offering, and I'm sure most of you might have heard one or maybe all of them. Let's start from the left, wavelength. So AWS announced wavelength zones, I think, a couple of years back. So wavelength zones, what are these? So they are like uh, data centers, AWS data center inside telco network. Okay, so if I have to give you one example, then it's like in India, we have Geo, right? Geo network, and in Geo, they will have their regional data centers and all. So inside their data center, AWS is going to host their own servers and all, and it will be directly connected to the network because network is given to AWS by, let's say, Geo, just for the sake of this example. So their data center will be inside their premises and connected to that. That is like network edge. Then whatever applications are getting connected to this wavelength zone, the traffic will not go to cloud. It will be locally routed, right? So that is called local breakout. So let's say I'm carrying a phone and I have an application and I'm edge computing user. So uh, when I subscribe to that application, uh, I'm the way I'm going to get that edge application is through local breakout. So whatever I'm doing on that application, it will be served locally from the wavelength zone which is nearest. It will not go to your central cloud. Now, what is the difference between wavelength zone and a normal availability zone? So wavelength zones are very good option for low latency application, and they are not as big as your normal availability zone. They're not very huge in terms of capacity. They are not. I mean, they don't support all kind of AWS services. So you know, right? In AWS, we have got hundreds of services, but wavelength zone support very few. I mean, handful of services. And as per, I think, few days back I checked, so there are like 19 cities in US where wavelength zone is present, and in Canada, Tokyo, Seoul. So I think it is available across the world, but it is not uh, as widely spread as normal AWS region and all. Now, what it provides, what wavelength zone provides, it provides pre-configured hardware, software, and the most important part is telco network integration. So the difference between wavelength zone and local zone is this telco network integration. So local zone is uh, any, I mean, it's like a small availability zone or a small data center present in big cities. So let's say tomorrow I want to launch an application for user group or users in Indore, right? So what I can do, if there is a local zone in Indore, I will host my application in that local zone so that Indore people get the best response time and throughput, right? Rather than hosting it in Mumbai or any other region. So that is local zone. So local zones are already there in GA in 16 cities in US, and there are 33 locations around the world where it's like announced it will come soon, and that also includes three locations of India. I think Chennai, Bangalore, Kolkata, something like that, right? So local zones will give you that kind of benefit, right? So let's say instead of connecting my application to US East one in North Virginia, I'm connecting to uh, I'm connecting or hosting my application in Atlanta itself, which is a local zone, so that I can serve this Georgia user very well. So that is local zone, but it does not have any relation with telco network. Now, telco network is required when you want to handle something on mobile application, and that mobile traffic should not go back to cloud, right? It should be locally served. So wavelength and local zone, you might have understood, they have quite similar kind of functionality. So the benefit that we get is consistent experience, right? So it's still AWS, right? So it's very easy to use and all. They have very limited service availability. Now comes the most important offering is this AWS Outpost. What is AWS Outpost? It's a hyper converge infra. You- and there are so many SCIs, HCI vendors out there, right? Like Nutanix and uh, Dell, and so many people give SCI. Now, what is the difference between those and this one? So this SCI, this hyper-converged infra, which is having compute, storage, network, everything, also has AWS software running on it. So, and that makes it so unique. I mean, it's like extension of AWS, right? And it is ready to run kind of machine. You just connect to your network and you're ready. Now, this is again one of the offering, but it has very limited service availability, and they are constantly increasing or bringing more and more services on Outpost. Uh, if this is not clear, just wait for few slides, it will be clear. So see what happens when you want to implement, let's say, edge computing, right? So what you need edge location, right? If you read this diagram bottom up, these are the requirement. You need edge location. Edge location could be at city level, it could be at a very specific location, let's say a stadium. So some big matches happening in one stadium, and I want to serve all the user, I want to give them best experience. So I will uh, use that stadium as self as a edge location, which might be a moving location, not permanent, and I will serve the content from there, right? So that is called edge location. Now, in that edge location, we need hardware, right? That will do the processing. So it could be, I mean, there could be various possibility of that hardware, and on that hardware there will be software components, and all these things should be connected to a network, right? Uh, and how do we implement it? I mean, you need all these four things. How do we implement? There could be three different approaches. One is do it yourself, means you find out the location, you get the hardware. I mean, this is the typical data center way of doing things, right? Where you build your data center, you get your hardware, you manage your software on it, you manage connectivity of your data center and all. So that is do it yourself. Very cumbersome, very costly, especially from edge implementation perspective, because edge side will not be one or maybe less than 10 the way data centers are present. Edge data center will be in hundreds and thousands. Right now, can you manage 1000 data centers, edge data center, in the same fashion you're managing your data, normal data center? You cannot, because you can't give hands and feet support. You cannot take care of that kind of security which is there inside your data center. You need a lot of zero touch automation so that you can do most of the things remotely. So you have different consideration for this stack, right? So do it yourself is the last thing you want to do. Next is using cloud providers like AWS. Now, how AWS is helping? And third approach is hybrid approach. Hybrid approach in the sense you use some of the offering from AWS, and you also go for do-it-yourself approach in very few cases. And let's say telco providers can go for this approach, right? Where they will use their exchange location as their edge data center, because they have exchange location in almost all the cities. So they will use that as edge location. They will repurpose that location as a mini data center or edge data center. Bring your hardware there and all. So, but do it only in the places where, let's say, AWS does not have local zone or wavelength zone in all the cities in Australia. Now I want to implement edge computing. What can I do? So wherever wavelength or local zones are there, I will use it. But wherever it is not there, I'll go for do it yourself. So that is like hybrid approach. Okay, now I have used four terms here. What is edge location? So it could be edge data center, and it could be small cabinet on roadside like a smart pole. So smart poles are getting implemented in different parts of the world. Very interesting concept. You can do Google and read about it. So it's a like normal lighting pole, but even it is implemented in Bangalore. If you go to Electronic City, there are some smart poles which have camera, which has environmental related sensors and whatnot. So it's like multi-purpose. So that is also one of the edge location, right? It could be a base station of, so you see a lot of mobile tower. In India, we have got like 7 lakhs plus mobile tower. Now, each of those mobile tower itself can become edge location. That's like extreme case of it. Or in fact, most extreme case will be these small cabinet on roadside. Just imagine how many of it we have to use and all. So this is not going to happen very soon, but uh, at base station and regional data center or metro data center, it's already happening. Hardware also has very special consideration when you're talking about edge, because when your servers are sitting inside data center, you have nice cooling and you have dust prevention, whatnot, right? But if they are out there on the road, right, roadside pole, you have put a server, then there will be temperature variation. You can't put AC there, right? So you need rugged hardware. You need specially purpose hardware. You cannot just use normal Intel x86 for everything, right? You might need maybe Jetson Nano or Raspberry Pi kind of very small devices, ARM based devices for certain use cases. So hardware will also be of so many variety. Software, when I say software, I mean I'm referring to everything: OS, application management, whatever. Connectivity, it could be 5G or it could be anything. I mean, it could be LTE, Bluetooth connectivity, all kind of connectivity. Now, coming to very interesting concept. So I know since it's a very new topic, you might be having so many questions. So just keep typing your question or just hold your question. After 15 minutes or so, I'll take those questions. Okay. Now, MEC, which is multi-access edge computing, is bringing a new kind of application which is called edge native application, right? So far what was happening, our applications were uh, written in such a way that they were not really focused on network, right? So they were just using network element, but now we are writing network aware application, right? So uh, earlier it was other way around, where application aware network was created, that this is my application requirement, so my network should be like this, right? But it's like reverse. So cloud native started long back. Cloud native, from cloud native we moved to Kubernetes native. Nowadays cloud native became synonym of Kubernetes native, right? Everything in cloud native is being done using Kubernetes, though it is not mandatory and not necessary. You can implement cloud native using virtual machine also, right? So it's not that. Now edge native is coming into picture, where you have also think about low latency, data privacy, high bandwidth, and I mean these unique requirement related to edge you have to consider in your application. So you will be using MIC APIs, let's say, right? So it's a new kind of application coming into picture, and a new kind of platform is also coming into picture. So earlier, a lot of telco terms here, so I would say just don't bother much. Earlier, OpenStack used to be the default solution for telco cloud, and all kind of virtual network functions or any kind of MEC application was running on OpenStack. Then came Kubernetes. With Kubernetes, OpenStack and Kubernetes started living together, because now there were applications which were virtual network function like VM based, and they were container based. So Kubernetes was used, right? But maintaining two platform was difficult. So now entire industry is thinking about a situation where Kubernetes can become the single platform to host even virtual machine and container. So there are already few solutions like KubeVirt. Uh, KubeVirt is one solution which allows you to run virtual machine inside Kubernetes. I mean, very difficult to visualize this, but yeah, that is how it works. So that you don't have to manage two platform, right? So that is where this platform types are coming into picture. And why are we talking about Kubernetes for edge computing? Because edge will have I mean, see, on the left side, I have just mentioned the requirement of Edge platform and whether Kubernetes can help there. So, Edge platform could be very small, also, right? As I said, it could be a Jetson Nano thing for doing small video analytics. Now, So you need lightweight kind of platform. You cannot run a virtual machine to do that kind of operation on Jetson Nano or Raspberry Pi. You need very small. And if you don't know, then just want to tell you that Kubernetes has some very small version also, like K3s, KubeEdge, Minikube. You might have heard, but Minikube is not something that is used in production. But yeah, K3s, KubeEdge are two, even Rancher K3s is already talked about. Yeah, so some small memory footprint options are required, and it is fulfilled. And it should be open source, not necessary, but very good, because when you're dealing with thousands and uh, millions of servers, then you want to save licensing cost, and that's where open source helps. And Kubernetes is open source, everyone knows. You want easy installation, offline mode operation, and so many other features are there. And it should work on public cloud, private cloud, bare metal, virtual environment. So all kind of possibilities are there, and thankfully Kubernetes runs everywhere, right? So portability is one key benefit of Kubernetes, and it should support various different kind of use cases. So there are different projects in Kubernetes world which handle this. Like for AI/ML, you have Kubeflow. For serverless, you have Knative, and so on, right? So that's why Kubernetes is the de facto standard for edge computing. And one other thing I forgot to specify, that 5G implementation has changed dramatically from 4G or LTE. So now it has become cloud native. And when I say cloud native, 5G core is all microservices based architecture. And you know, when you have to implement microservices based architecture, you need some container platform. So that will be Kubernetes. That's why EKS kind of offering is going to be very, very useful in this case, right? So 5G is cloud native. That's why all the people who are working in cloud will have a role to play. In the past, I was involved in doing one project where we implemented AWS Outpost and EKS based edge platform. Uh, and how does it work? So Outpost, as I said before, it's a ready to run kind of server. It comes in various form factor. 1U, 2U are something which is recently launched, but 42U is like full size rack, right? 80-inch rack. So this was always available with this form factor, but these are new ones. Now, uh, so you remember the diagram where I was showing edge location, hardware, software. So hardware, software is AWS Outpost. So it's a hardware. It also has software. Now, for container-based container hosting platform, you can use EKS. EKS is fully supported on AWS Outpost. And when I say Outpost rack, I'm talking about 42U. And for 1U, 2U, we call it Outpost servers. Now, EKS also has a open source distribution called EKS D for distro. This can also be used on Outpost servers. So let's say you're using 1U, 2U server. Now, 1U will not have any high availability, right? It's just 1U server. So you cannot install this full-fledged version of EKS. You can use EKS D there. Uh, Now, EKS cluster can be entirely hosted. This is a new feature that I think was released last month only. Earlier, whenever you were running EKS cluster on Outpost, your control plane was always running in main region, and your data plane was running on Outpost. But now, uh, and there was drawback of that approach, right? Because then you always need a connectivity between Outpost and main region. So you cannot run it in disconnected mode, which is one of the requirement of edge computing, where things should run in disconnected mode. So if I'm running application inside a mine, right, I will not have any connectivity there. So for certain duration, I'm saying forever, certain duration. So application should work. So that's why AWS has now given this feature where you can have your control plane also uh, sitting inside the outpost. Okay, now If you want to implement network edge is again type of edge that telco provider use, and it can be implemented in two ways. So you can use EKS on outpost, which I have already explained. But let's say you don't want to use outpost, right? For some reason, let's say you have already invested in your hardware and you want to really use that investment rather than going for new investment before hardware refresh cycle comes. In that case, what you'll do, you can use EKS anywhere on bare metal if you want to run it on bare metal, or EKS anywhere also supports VMware vSphere, right? So it can run on any of this. uh, Difference between EKS and EKS anywhere. EKS anywhere is basically for on-premise version of it, right? So it's same EKS, but this guy is for cloud and this guy is for on-premise. EKS anywhere does not run on outpost, remember. Now, how how can we implement 5G network on AWS? I have shown one news, right, where one of the telco company has implemented 5G network on AWS. How does it work at very high level without getting into detail? And you can read this white paper which is given here. Uh, Link is given here. You can read this. So this is a reference architecture taken from that white paper. And key highlight of this architecture is that when you want to implement 5G, you will use your normal AWS region, and you will also have some on-premise kind of component which will be running on AWS Outpost, right? You see two outposts here, and control plane and some services. These are all microservices of 5G core. Some will be running in cloud, which are like not latency kind of microservice. So you will run those here, and there will be so many services like DevOps services will be used, monitoring will be used, and so on, right? So uh, those can be used here. This is very high level architecture. How do you implement private 5G? I know it is too much of information on this new topic, so I'll not get more into detail. I think this will be my last slide. So private 5G network. What is private 5G? So 5G brings so many new functionality. One is private 5G, another one is network slicing. So private 5G means uh, you basically own your network. So right now we are relying on communication service provider, right? Telco providers to get us the network. So any industry, any company which wants connectivity has to go to any of these telco provider and say, give us the connectivity, and they will give it in some form. Now, if you have data privacy requirement, uh, if you want consistent uh, service, right? So many reasons actually for doing that. You might want to go for your own network, but it was not possible earlier because spectrum was not given to anyone and everyone, right? You can't buy spectrum. I mean, tomorrow I can't say I need a spectrum. Can you give me? First of all, it's not that cheap, and second, it's not given to. It was not given to small companies. I mean, any company apart from telco provider. But from 5G, it is allowed, and there is CBRS kind of a spectrum which is already available in US. So this private 5G offering is based on CBRS. Uh, so here spectrum allocation is AWS responsibility. Okay, if you read this line, is AWS is responsible. So no telco provider is coming into picture. And what AWS is doing, they are giving a private 5G network in managed service kind of offering, right? So how AWS can do that? See, AWS is not a telco company, right? So they don't earn any network. So they are using CBRS spectrum, which is there in US. So right now the service is only in US, uh, and they have tied up with various NEPs, which provides these equipment like you see those uh, radio unit, right? Across all the roofs and all. So it buys those radio cell unit and software that runs on that cell unit and core software and SIM card, whatnot. I mean, right? So they are just getting everything and selling it as a service where as an end user company, you don't need to really bother whether this radio unit has come from Nokia, or this came from Avenir, this came from uh, anywhere else, right? Or again from Avenir. So all, I mean, your interaction will only with AWS, right? So the benefit of managed service, right? You have single neck to choke, uh, and it's pay as you go offering. It's very difficult. I mean, all said and done, implementing private 5G network for a company which are not telco, it's very difficult. So AWS is helping there. They are taking all the overhead or management overhead to themselves, and they are solving it. What is the benefit of it? It is primarily used in manufacturing plant with lots of IoT devices. In fact, today in IMC, nice demo was shown where from Dwarka metro tunnel, I mean, just imagine inside the tunnel, one of the officer called inside the tunnel, and there was live video call happening from that tunnel to our prime minister. So uh, that's like dedicated network, right? It might be some sort of private 5G network that they might have implemented, right? So uh, this is very interesting concept, and network slicing is even more interesting, where you get a dedicated slice of network, right, which is going to be with you, and it will give you consistent experience and all. So you might read about it. So private 5G net on AWS is already GA, right, in three regions, mostly US. Now, what are the key takeaways? So edge computing, especially edge computing and private 5G, there is deployment cost, there is deployment complexity, and security. So it's very, very capex oriented business actually. So, I mean, if you think telcos earn a lot of money by having millions of subscribers, then that is wrong. Telcos are like bleeding because the amount of money they spent on setting this infrastructure is extremely huge. They spend billions and billions of dollars, right? And these are key challenges. So obviously, you need to go with some as a service or pay as you go kind of thing that will make this life simpler and easier. Now, because another big challenge here is that there are no killer use cases for edge computing. We are talking about remote healthcare, we are talking about autonomous car, but let's say autonomous car, it's far from reality. It will happen maybe in after next 3 years, right? So ROI is not very obvious for companies which are investing in this. Right? So that is a challenge. And offering like AWS Wavelength helps in some way because then I don't need to really worry about anything. I just need to deploy my application and I'm ready to go. Right? And Kubernetes, you might have understood by now that Kubernetes has very strong role to play because of cloud native nature of 5G and all the CNF hosting capability requirement. So it's going to get a lot of momentum, and we are moving towards edge native application. So that is about it. And now we can take questions. Nipun, are you there?
Yes, I
Yes.
am there. Uh,
Okay. Will you
Now,
read out the questions?
sure,
If you
sure, sure. So I'm also there is a less number of questions, so we are not going to disturb you because we know like there is a thought process going on. So first question is there for the Divyan Thakur. It is like what is the use case of hyper converged infra specialist specifically, sir?
okay. So see what happens when you want to deal with volume. You don't want to do it in traditional way of buying, let's say, a compute from one vendor, storage of SAN storage from other vendor, networking equipment from third vendor, and management software from fourth vendor. Right? It is okay for data center. You can still do it for, let's say, four data center. But when in edge computing we're talking about thousands of edge sites, so you need ready to run kind of boxes, edge box, if you can visualize it. I want edge box which I can just give it to a person who is not even IT person, who is driving the truck, and I will ask him to just put it somewhere in that site and connect with some cable, and when he powers on, it should come up and it start running, right? You want that kind of option, and that is only possible when you are using hyper converged infra, where uh, your storage, your network, your compute, and even software, everything is bundled and ready to run, right? So that's a role of HCI in this whole game.
Right. I hope we have answered your question, Divyansh. And one more question is there from the Divyansh only. Like, uh, he is not particularly familiar with the particular edge computing and the 5G. So, which are the good documenter from which place they can able to explore the things?
So for edge computing, I would say Etsy website, ETSI. Etsy website is the main source because they have defined all kind of MIC standards, and 3GPP standards also can be reached. And some edge computing books are also available in the market, but I don't think so. There are courses and all in that area, but yeah, Etsy and 3GPP website I would recommend. NGMN is another place which gives nice white paper on 5G edge computing. Yeah,
Right.
and you can get in touch with me on LinkedIn and also we can discuss.
Definitely, definitely. So this was there about the question and answer part. Like moving ahead, and let's move toward the conclusion because we are bang on time. Like we are working on perfectly on time. So I'll just remove your presentation and back to the StreamYard. Uh, Thank you for a wonderful session. Like it was a very amazing, and specifically like 5G. We have just heard the name. We are not experienced and we have not much knowledge about it, but it was very insightful. Like as you mentioned, like today, like in the Delhi, some conference or the meeting is going on, and PM was addressing the things. So that was a great insight for us. And one more thing I personally like, that is of the Kubernetes. As you mentioned, like in Kubernetes, we can also deploy one more virtual machine. So that was a thought, like very big deal, and I it's keen for me to understand the things. So that was my personally best part to of the session. And yes, thanks a lot, Abhinivesh. We know like your thought was not good, and then also you delivered the session. So thanks a lot on behalf of the user group Rajkot, Indore, Kolkata, and Jaipur. And I hope all of the guys have the great learning from this session. And yes, thanks a lot, Abhinivesh.
Thank you all. I mean, I would like to thank all four user groups for giving me this opportunity. It was wonderful. I mean, as usual. Uh, Thank you so much.
Thank you. Thank you, guys. Have a nice day ahead. Bye, guys. Bye, Abhinivesh.
Have a good weekend. Bye. Thank you.